You've got one now. All right, well, how about that? Great.
Hello? Hello? Okay. So my project for the hackathon is called WaitStat. So I just want to take a quick poll. How many people here have had anxiety either waiting in a security line, worried about maybe missing their flight, or maybe you're traveling to the airport and you're not sure how long the security line is going to be? Just raise your hand if you've had that anxiety. Okay, so most of you, right? So why do we not have real-time stats about waiting lines at the airport? It seems like most people would want to see that information before they go to the airport, and also when they're in the airport, they probably want to know how long it's going to take to get through. So my project tries to solve this issue. And we see it even on Twitter, people complaining about wait line anxiety. The TSA currently does have sort of a solution. So for certain things like TSA pre-checks, they allow people to report their waiting times through the phone. So it's more crowdsourced information. But the issue is that it's not many people use it. So you can see like maybe once a day, people are reporting their waiting time. So it's not really that useful. So what I propose is that the airport actually puts sensors in the security lines for the airport security. So the dotted line represents the waiting line. The gray box down here is the actual security checkpoint, and then the entrance is at the top. So I propose that you can put sensors throughout the line, which will measure sort of how many people will be waiting, how many people are waiting in line. And this information can feed to a centralized server, which could then feed into people's phones, or maybe it can be exposed to the SFO API to be integrated onto different websites. So I built a prototype using Arduino last night. It's very simple, and obviously if this was productionized, it'd look much better. But this was just a proof of concept, and the basic, the main component here is this range binary component, which can basically tell the distance that person is standing in front of the device. And here's an example app of what that information might look like once it's reported. So the user could pick a terminal, and then they'd see how long the waiting time is. So let's actually try the demo. Hardware demos are always kind of tricky, but let's see if this works. So on your mobile phone, you can actually go to bit.ly/sfohack to see the web page. And I have the sensor actually here right now. And does anyone want to volunteer standing in front of it? Basically, we're going to pretend for this example that it's contrived that 1 centimeter represents 1 minute of waiting. And so, so if we go to the website now, you can see that I have this, maybe you can slowly walk forward, and you can see that the distance should be slowly increasing in terms of centimeters. Yep, 32. And that should be reflected in the web page here. Yeah. The internet connection is a little bit flaky here, so sometimes, let me just refresh to see if it gets updated on the right-hand side. If not, I can force the update. Okay, maybe while we're waiting for that to load, we can go to other parts of this. So, actually, let me just, okay, I'll go to the other part. So, another piece is this walking time. So once you pass the security line, basically you can see, this is using the Esri API. I was talking to some of the folks earlier about this, and basically through the API, if you provide the source and destination, then you can get the walking directions, and then from there you can estimate your walking time to your gate. So for example, the user can then see it takes 10 minutes to go there. So this is using the Esri API, and then also using the SFO API, users from this app can see what are some of the things to do around the airport. So since this is an update, I can force an update through my laptop here. Okay, yeah, so now, so let's say, yeah, it's 30 minutes or 25 minutes. If I'm forcing the update, then it gets reflected directly into the app.
Based on that distance. All right, okay, Alec, your 3 minutes are up.
Okay.
Thank you very much. Good.